Hi, and welcome to session 9, I think it is. So we're doing really, really well. We are concentrating just on those circle theorems. We want to make sure that we are really practicing that. So rather than mix it up, I'm just doing circle theorems. We're going to go back to mixed ones for the next session. But for today, this is what we're going to be seeing. There's 5 questions in total. So I want you to pause. Feel free to look at your notes. Do not feel like this has to be a test. Obviously, the more you can do from memory, the better, but that's not what this is about, okay? If you need to look things up, then please do. So hit play when you are ready to hear the answers. Okay, so first thing you've always got to be doing is looking at all the detail in the diagram, because different detail can lead to different theorems and then their applications. So I can clearly see that this has a center point. Now, center points are great for that arrowhead. It's really nice when it appears that obviously, okay. We've got radiuses, so I might mark that on straight away. I know that those two are going to create me an isosceles. I've got a tangent, so I'm very highly likely to have the chord and the tangent here meeting. So I've got that alternate segment theorem going on as well. Okay, I could mark that in if I wanted to. So obviously it's not going to be the angles touching that chord, but the one in the opposite side. And I'll just color that in. So it's all of that. So I know part of it. I know some of it's 19, but I don't know it all. Okay, but I go back to this isosceles. This isosceles triangle here is actually going to help me find the missing part of that angle. So we would be doing as working out 180 minus 122, which would give me 58. I need to obviously share that between both angles, which means that this angle is 29. Okay. What did I use to do that? I used isosceles triangle. Write your reasons as you go, okay? Then I am going to do 29 plus 19, which equals 48. So A is equal to 48 degrees using the alternate segment theorem. And when you are writing this in your exam, write it in full sentences so there can be no ambiguity. They have to give you those marks. So that's the first one done. Okay, second one, stop and digest what you're looking at. So again, I can see that a center point's been marked on, which means that has to be a diameter. I can see that a chord has gone through and they've actually popped the lines on for me. So that's definitely confirming I'm looking at a diameter bisecting a chord, which creates a right angle. So I'm going to mark that on. I know that that is going to be a right angle. And then I can detail that. I can say diameter chord equals 90 degrees, something along those lines. Okay. And then I can see that there is a triangle here, which means I can now find D. So I'm going to be doing 180, take away 90 plus 21. Okay, that's going to give me 69 degrees. Now I've got to work out C. It would be very tempting to say C is 21 because the diagram really looks very symmetrical. And I do know that because of the bisecting, that they're going to share at least one of those angles, but I must never assume. I've got to prove it. And when I do that, I learn that it isn't actually quite the same at all. There is another sneaky little isosceles in this diagram that you may well have missed because I don't think it's that easy to see. But what you've got here is a center point. So that line there is a radius. And that line there is a radius. So I have got myself a isosceles triangle at that position there, where it's starting to get very colourful, isn't it? So if these two are the two edges the same length, then these two together are the same angle size. We already know that D is 69 degrees. So what I am going to be doing to solve this one is 180, take away the 69, okay, which will give me 111. And then I need to half that by 2 to give me 55.5. So I know that these angles here and here, the whole of it, not C, but the whole of it, are 55.5. So the last step would be 55. Should we pull this up a little bit? 55.5 minus 21, which is equal to 34.5 degrees. Okay, so I have used my isos triangle in 2 places to finish that particular question. Okay, over to the third one. As always, that arrowhead, when they draw the diagrams like this, it's really, really easy to see. Now over here, we didn't even use the fact, but over here, we will be, okay? I can see I've got a center point. So I know that I have got an isosceles triangle with the 2 radii there. So if that's 52, that's 52. And if they are 52, then I can work out by taking them away. 52 plus 52. Take that away. I've got 76. So I know that that is 76. E, which is the one we're looking for, is half the size. This is the twice, the angle at the center is twice that at the circumference theorem, okay? So I'm going to divide my 76 by 2, which will give me 38. Whoops, put the 3 in as well. That will give me 38. And like I say, it's, I shall write it in very shorthand. Twice center than circumference, something like that will do, okay? And obviously here I used the isosceles triangle. Ooh, squeeze that in. Now isosceles, you can see just how much it comes up and how useful it is in our problem solving. It's a really big one actually in circle theorems. Okay, so that's the first 3. Hopefully they went well. So we're going to move on and do another couple. So let's pull those up. I will just clean this off so you've got nothing interfering with your screen. So again, I want you to literally pause and have a go at both those questions. Just do your best, use your notes, and then when you're ready, hit play. Okay, so the first one, I think the cyclic quad stands out quite nicely. So I can kind of see straight away that the P and the Q will add together to get 180. So as long as I can get one of those, I can easily get the other. So I've not got a massive amount to go on, to be fair. I can see I've got 104 over there. It's not a tangent. There's no radii or diameter or anything like that in this particular diagram, so I can't rely on any of those theorems. The most obvious first step would be to work out this one on the straight line. So 180, take away 104 is 76. I've used my straight line equals 180 to solve that, and I'll just mark it on 76. Okay. Now, this angle that I've just found is made with that line there and that line there. Those 2 points, let's get them to stand out. Those 2 points will travel along the lines to the angle 76. You can also move from those points here and here to go to another angle in the same segment. So P has to equal 76 using the same segment theorem. Just going to bring that up a little bit. Okay, and now I've got P, I can get my Q, 180, take away 76, that's equal to 104. So Q is 104 because the opposite sides of cyclic quad equal 180. All right. Okay, last question. Quite a busy diagram, lots going on. So let's just stop before we do too much and just try and take in everything. So I obviously got some angles given to us. I've got a Y and an X. This X is at a point well outside the circle, and there's actually a tangent coming in from that point at two places. So that tells me that these lines here are going to be equal in length. Okay, so that's one of our theorems, isn't it? That two tangents from an external point are equal in length, something along those lines. So I can see that. I might as well mark that on as I go. I can see that obviously I've got those tangents. There's no center point, so there isn't a radius coming into it. This line and these lines are coming in to meet at that point, but they are chords. Now, when I recognize that, I then should hopefully trigger that alternate segment theorem. Okay, that's always a tangent and chord that feeds that. So the tangent and chord is going to help me fill in some of these blanks. I'm not going to massively concentrate on Y or X. I'm just going to use my knowledge to start populating angles within this diagram and hope that that just generally leads me around the diagram. The caveat, especially for this one, but actually for all questions, is that there is more than one way to do this. So what you're going to see is me demonstrating the way my eyes are taking in the diagram, the way my brain is processing with the theorems. And it's just one way to move around the diagram. It's not the only way. So if you're watching this and you're thinking, oh, I didn't do it like that, I must be wrong, you may well not be. So keep watching to the end to make sure that your angles are the same. If you did it a different way and you've got evidence to back up your steps, but you've got the same answer, then you're right. There is just more than one way to usually do the majority of circle theorem questions. So you may well have already experienced this. Okay, let's get back to it. I am going to highlight this 70 here. Okay, there's the tangent and there's the chord that make it. Okay, now the opposite angle cannot be touching this chord. That's why it's really easy for me to eliminate these two and go straight over here. So that angle there must be 70 degrees. Okay, now my brain is thinking, if I knew what that was, then I've got a straight line rule that will get me to Y. So that's what I'm going to do. I'm going to be considering the chord and the tangent that comes in here. So I've got my chord that comes in here and makes this angle that I'd love to find with the tangent there. So I've got my chord and tangent creating this angle. This one and this one has nothing to do with this, but this one over here does. Okay, so it's worked out well. Sometimes you might try something and just draw a blank. It doesn't really matter because you'll then just try something else. Okay, so that angle must be 55 degrees. Okay, so I found the 70 and the 55 that I've marked on using the alternate segment theorem. So I'm going to just point and arrow to that, make sure my examiner is really clear about what I've done. Alternate segment theorem for that one. Now, Y is going to be equal to 180 take away 70 take away 55, which is actually 55. So y is 55 degrees as well. If you put y being 55 degrees against alternate segment theorem, then that wouldn't be correct. It is because we did it on a straight line. Okay. I've got my y. I now need to get my x. My x is actually really simple at this stage because of the fact that I have an isosceles going on here. I have already found a 55 here, which was rather lovely. That means that this over here must be 55 as well. Okay, so x is going to be equal to 180 take away 110. So x is going to equal 70 degrees. And that, now this is where you've got to be careful. Yes, it is isosceles, but be careful not to say it's because of an isosceles triangle. It may not, it might give you the marks, but it may not. Really, it's an isosceles triangle because of the tangent from a point rule. So really, you want to make sure that that's clear. So x is 110, x is not 170. X is 70 because two tangents from external point are equal in length. Written that one out in full because we haven't seen it for a little bit and we might forget. Okay, I hope that went well. I hope we're starting to feel a bit more confident now that we've done quite a lot. So from here on in, it will just be a couple of questions in amongst all the other stuff that we've been doing, as I said. All right, what are we doing today? We are going to be doing parallel and perpendicular lines, but we're taking it up a level. This isn't just about drawing them on a grid. This is about actually working with them algebraically. And I'm going to be showing you a formula that it's just brilliant. I'm a massive fan of learning one thing and being able to use it everywhere. So this formula, a lot of teachers are often hesitant to share with students unless they're going for grades 8s and 9s and things like that. But I just think it's a straightforward formula. It's very straightforward to use, and it will answer and solve any problem at any level. So if you are building your skills, it's never going to cap you. It's always going to work. And that is why we're going to do it today. All right. So the graph and the diagram here is really just to remind us what we mean by parallel, what we mean by perpendicular, and then we're just going to be getting on with the actual algebraic approach. Okay, so let's have a little look. If we look at this black line here, okay, it is parallel to the blue line, and you can physically see, I'm going to do it this way, you can kind of physically see that the lines where they are parallel must have the same gradient. Now the black line actually is y equals a half x, okay, and it's going through +2. So the gradient for that line is a half. The gradient is always next to the x. Okay, so the blue line must have the same gradient. It is also half an x. That is not going to change. What will change is where it's intercepting the y-axis. So for this one, it's intercepting between the 4 and the 5, so it's +4.5. So very similar equations with the exact same gradient, which makes them parallel, and then just where they're slicing through the y-axis, which we call the y-intercept, that's the only thing that's going to change. All right, so they're your parallel lines. If we look at the red line, okay, the red line is cutting through both the blue and the black. It's cutting through at right angles, which is what perpendicular lines do. They cross or they meet at right angles. So those there are absolutely 100% right angles. If I look at the equation of the red line, it is y equals, it's a negative gradient, I can see that, and it's 2x, and it's crossing the y-intercept at +7, okay? It's minus 2x plus 7. Now I'm going to just pause and remind you of how you do a gradient. We don't need this at all for what we're about to do, but I think it's important if you're sitting there going, well, why is it -2? You're just telling me it is, but I don't know why. If you're feeling like that, this is why, okay? I shall do it with my red, I think. If I choose a point, I'm going to choose this point here. So I don't know if you can see it. Here's my red dot. I'm going to choose this point right here because it's going into a perfect square. I could choose any point I like. And what I'm going to do is I'm going to go back just one square, and then I'm going to go up, and I'm meeting in to another perfect corner. Okay. So I've gone back one, okay, so my gradient, remember it's rise over run, so my gradient has gone back 1, now that's the run, so I've got to put that on the bottom, and it's gone up 2, which is the rise, and -2 divided by 1 is -2. Now, we're not doing anything with rises and runs today. I just really wanted to remind you what that was so that you could see it. And you can see on the black one here, my run is at 2. So let's put that there. And my rise is 1. And that's where that half gradient came from. So if you were just wondering where I actually got that information, that's what was going on, okay? As I say, we're not really going to need it. The visual is there just to help us because it's what we're familiar with when we're working in this topic. Okay, we're going to do some examples, see this formula and work out exactly what we are doing here. I'm just going to move this down so you can see what it actually says. There you go. So we're going to be finding the equation of the line, which is parallel to another and passes through a particular point. So this type of question might look something like, here we go, let's write this one down. Y equals 5x minus 7. Find the equation of the line which is parallel to y equals 5x minus 7 and passes through the point 1, 8. So we're given this piece of information to write another equation. Now, before we get started, I just want to give you a little bit of a bigger insight into where everything's working in the formula that I'm about to present to you, okay? So when we look at this equation, the general rule for this is y equals mx plus c. The m, the number stuck to the x, is how steep our line is. That is our gradient. Okay. Our c is our y-intercept. Our y and our x, which often gets lost and forgotten about, they have a role as well. They are actually the coordinates that sit on the line, okay? So our y and our x are actually x and y coordinates. Now that's a really important and valuable fact to remember when we're involved with y equals mx plus c. If I've got to write an equation, then y and x will be in that equation along with the gradient and intercept as a numerical value. The formula that I'm going to use in all the work that we do from now on derives from all of this knowledge. The formula looks like this. Y minus Y1 equals mx minus x1. And when you first look at that, it feels really, really scary. You'll also notice there's no C. There seems to be everything else from our general rule, y equals mx plus c, but there doesn't appear to be the C. That's because this formula itself will generate the C naturally, and we never have to think about it, okay? You can see from our question here that we have a gradient. We have a gradient here in the equation, and we also have a coordinate. Now, this coordinate belongs in the y1, x1 position. I hope you're keeping up with me. It's a lot of information, isn't it? So my coordinate here, I've got coordinate x1, y1. I've also got the gradient, which is m equaling 5. So when I look at this information that they've given me, I can straight away pick out my gradient and my x1, y1 information. Okay. At this point, I would then write down my full formula. I don't take shortcuts. I don't not write everything because I do not want to make a mistake. And if my eyes are feeding that information, it's incredibly unlikely that I will make a mistake. If I'm making my brain think about it and process the work at the same time, anything can happen, especially with my brain. Okay, we're going to start putting in the information. So I've got y minus y1 is 8 equaling m. M is 5, bracket, x minus and x1 is 1. I've now created some maths that I need to expand on this side. Okay, so I've got y minus 8 equals 5x, and 5 times minus 1 is minus 5. Now I just need to get rid of that minus 8 to get y on its own. So minus 8 will come along and land as plus 8. So I've now got y equals 5x minus 5 plus 8 is plus 3. And that is the equation of the line, which is parallel to this one, and that passes through the point 1, 8. Y equals 5x plus 3. It really is just organize the information, substitute it into the formula, do the maths it creates. Don't let the detail that comes out when you first see it be the thing that confuses you, okay? The detail is just trying to give you the kind of backstory, the why it works story. But the reality is, if you think y equals mx plus c, that's got a formula, learn the formula, get that absolutely secure in your head, then there isn't a question out there you can't do. This formula does everything at every level, including A level. We use this formula, okay? It's a brilliant, brilliant piece of maths. Does anything we need it to do when we're problem solving with straight lines, but there's no graph. Okay, let's look again at this because you've got a lot of information in that one, and it will be easier, or at least I hope it will. It'll be easier when we just see it flowing rather than see it with all that information. So this time we have got y equals 8x minus 1, and we've got the coordinates minus 3, minus 5. You could write the formula down and then get the information, or vice versa. I'm going to write the formula down because actually writing it down reminds me what I'm looking for in the first place. So my formula is y minus y1 equals mx minus x1. So I need my x1, y1, which is over here. So x1, y1. Remember that your coordinates are in alphabetical order. So that's an easy way to make sure you don't mix those up and put them the wrong way around. I'm also going to need an m, which I have, thankfully, here in the equation they gave me. And now I can clearly see what it is that I'm going to be putting into my equation. So I've got y1 is -5. Now, I quite like putting that into a bracket. I don't think you have to. I don't think you need to. And I think if you don't like it, then don't. It can just be useful, and it's a nice way of dealing with negative numbers. The m is 8, and then I've got x minus, and then I've got -3. -3 going in there. Close the bracket. Right, let's do some of this maths. I've got y plus 5 equals, I'm going to expand this, 8x. And then here, those two negatives make a positive. So I'm doing 8 times 3, which is 24. Just need to get that y on its own. So we're going to pick that up. It's going to land as -5. And I've got y equals 8x, and 24 minus 5 is 19. So this equation here is the equation of the line that is parallel to this one and passes through these coordinates. Okay, hopefully it's starting to feel not quite as hard as maybe you thought. We will see, won't we? All right, we're going to do one here, which is slightly different. So don't worry, I'm not asking you to have a go with this. I'm just asking you to see what's happening. I've got x plus y equals 4, and the coordinate 8, 8. And it's the exact same question. I've got to work out the equation of the line, which is parallel to and passes through. And that doesn't look right, does it? Okay. My straight line, equations of lines, straight lines, are y equals mx plus c. That's my comfort zone, and that is my general rule. And that doesn't look anything like it. So all they've done is just hopped the x over to mess with your head and make you feel like you can't do this. So we've got to watch out. They're sneaky, and we've got to watch out for when they're doing things like that to us. So all I've really got to do before I can start working on this is just get that x over to the other side so that I've got my y equals equation. 4 is already there, so I think I'll just leave it there. This is going to land as -x, and obviously my coordinate hasn't changed. So my formula, y minus y1 equals mx minus x1. Okay, I've got my x1 and my y1. When they're the same numbers, it's not really make much difference if I do get it around the wrong way. Now, looking at my equation, okay, it is the number in front of the x, and in front of the x is actually a negative. I've got a negative 1x. I just can't see the 1 because we never show the 1, but that is -1 in front of that x. So m is equal to -1. So let's start putting this in. So we've got y minus 8 equals minus. Now you can just put it up against the bracket. That would be quite standard. If you feel that you need to see the 1, just put it in there. It doesn't make any difference. You're certainly not going to lose any marks for doing it. Okay, so I've now got y minus 8 equals minus x, and then -1 times -8 is +8. I'm going to get that y on its own by moving that across. It's going to land as +8 to give me y equals -x plus 16. And what we've just done is written the equation that is parallel. And you can see it's parallel because I've got a -x here and I've got a -x here. So it's parallel and passes through these points. Okay. All right. Let's now take a look at this type of question. Okay, find the equation of the line which is perpendicular to and passes through the given point. So this time, it's really, really important that the equation that I end up with at the end is perpendicular and not parallel. So those gradients won't match anymore. Okay, so if I take you back just a sec to what we were talking about right at the beginning when I actually had the graph, if you remember, I had a line, I had another one that met it, and they were perpendicular. The line was positive half for the black line, if we remember, and then we had a -2 gradient for the other one. If I multiply these two gradients, okay, so I'll put my time sign in. I always stick a whole number over 1 to make it really easy and turn the whole question into multiplying fractions. Multiply along the top, 1 times 2 is 2, 2 times 1 is 2. I've got the one negative there, and that gives me -1. Okay, and that is true of all perpendicular lines. It's a way of being able to identify if lines are perpendicular. So I could ask you a question, is this equation perpendicular to this equation? And you could be sitting there going, oh, I don't know. All you do is take the two gradients, multiply them, and if they equal -1, they are perpendicular. If they do not equal -1, then they are not. And they sometimes like doing that kind of thing because it tests if you've got that piece of knowledge secure in your head. But that is true. I don't tend to work my gradients out with this, it has to multiply to -1, because there's another condition that's going on here. Okay, if I've got a half and take the reciprocal of that number, the reciprocal just flips it. 2 over 1, and 2 divided by 1 is 2. So I can use this flipping action in order to write the perpendicular gradient, but I must remember that it's the opposite sign. I've got a positive and a negative, one going up, one going down to create me that right angle. Okay, so we must remember that as well. We'll see it in practice as we go. Everything else is the same as the parallel lines. So we're already familiar and using the formula. The only difference is going to be a little bit of work on the gradient, and that is it. So let's have a little look. Let's actually see this so that we can see it's not that tricky. So if I gave you y equals -3x plus 1, and we're going to have the point 9, 8, and you're being asked to find the equation of a line. If you're being asked to find the equation of a line, that is your trigger. That's what's got to get your brain to go, ah, there's the formula, okay? So my formula is y minus y1 equals mx minus x1. Let's change the color so it stands out. My x1 and y1 are here. My gradient for this equation is -3. I have to change that gradient to one that would be perpendicular. So I'm going to flip the 3. Remember, 3 is a whole number, looks like that. So when I flip it, it's going to look like that. Also, this is negative. So this was negative to start off with. It now has to be positive, right? Flipped and opposite sign. That's what you need to remember. Flip, opposite sign. So this is going to become, is going to be a third. That's what I'm going to be using. And now I do exactly what I was doing before. Nothing has changed. So the only extra piece of work, this question with the word perpendicular instead of parallel, means just a little bit of extra work to remember to do here. The rest of it is the same. Okay. So I have got y minus 8 equaling a third of x minus 9. For me, at the moment, getting confident with this is way more important than worrying about whether you can do all this maths in your head. And if you want to be grabbing a calculator, please do that. To be honest, most of the time, this is on the calculator paper anyway. So you're more likely going to have one. If it's starting to feel easy and it's a walk in the park, then maybe challenge yourself by putting that calculator away. But at the moment, if you're wondering, should I use the calculator, shouldn't I? Just do. Just make your life easier by using the calculator for this if you would like to. Okay, so let's keep going. I've got y minus 8 equals a third x. So I've just expanded that bracket. Over here, I'm going to be doing a third times 9. Okay, that's basically going to give me 9 divided by 3, which is 3. And I've got the negative as well to consider. So my answer there is minus 3. The minus 8 will come across so I can get that y on its own and land as plus 8. So my final answer is y equals a third x, and then minus 3 plus 8 is 5. So that is the equation of the line, which is perpendicular to this one and passes through this point. Okay. All right. I think it's about time you had a go. All right. So we're going to do y equals a quarter x minus 7. The coordinate is going to be 1 minus 9. And you're just going to go for it. What have you got to lose? It will help you test your understanding of what we've done so far, because a lot has gone into this already, hasn't it? Just have a go and then hit play when you're ready. Okay, so it's y minus y1 equals x minus x1. Write it out every time. Do not give your brain a chance to forget this in any way, shape, or form. So I've got my x1 and my y1. Here, remember, I have got to work on this. It's not parallel, it's perpendicular. It needs a flip and an opposite sign. So a quarter is going to flip to 4 over 1, which is 4. All right, so it's going to be 4 with an opposite sign. Okay, so it's gone from positive to negative. Now I can put this information in. I've got y minus 9 equaling minus 4x minus 1. So y, the two negatives are going to make a positive. We've got minus 4x, and then be careful with your negatives. Minus 4 times minus 1 will give me positive 4. We now need to get that 9 away from the y so that I've got my y on its own. It's going to land as minus 9, and 4 minus 9 is minus 5. So it's minus 4x minus 5. And if you got that right, good work. Really, really well done. It's quite a lot there. There's no shortcuts. Don't try and take them, and then you will not get yourself in a pickle. All right. Okay, let's do another one. So we're going to do y equals 8 minus 2.5x. And we're going to have the coordinates 15, 2. So again, I want you to just pause, have a go. If you get a little bit lost at the beginning, then you can always hit play, get to the bit you wanted to know, and then pause to finish off. You don't have to play it all the way through. You can just play a little bit, get the hint that you were trying to get, hit that pause again if need be. All right, so hit play when you're ready. Okay, so we've got y minus y1 equals x minus x1. We've got the x1, the y1. And we've got our gradient here, which is minus 2.5. Okay. And I've got to work on the reciprocal of that. Now, this is a nasty little thing that they will possibly do to you, because it's not so easy to flip if you can't actually see the flipping that you need to do. And by putting it into a decimal, we can kind of lose that and hide it a little bit. Now, if it's on a calculator paper, all you're going to do is put 2.5 into your calculator, press equals, and it's going to give you the fraction version, because your calculator is set by default to give fraction results. So if you did that, your calculator would tell you that it's minus 5/2. If it didn't do that, then obviously you would have to be doing it by hand. Doing it by hand isn't overly tricky. 2.5 is 2.5, and then 2 times 2 is 4 plus the 1, and you've got your 5/2 that way. It doesn't really matter. Okay, so minus 2.5 is equal to minus 5/2. I want to flip and take the opposite sign in order to get my gradient, which is going to be positive 2/5. Okay, so my m that I'm going to be using is going to be 2/5. And now I can start putting all of that information in. So I've got y minus 2 equaling 2/5, and then I've got my x minus 15. I've then got I'm going to do my expansion first, make sure I've got that clear. So 2/5 times x is 2/5 of x, and then we've got 2/5 times 15. Okay, well, 2 times 15 and then divide by the 5 is going to give me 6. It's a negative 6. Get rid of that minus 2 so that I've got y equals 2/5 of x minus 6 plus 2 is minus 4. Okay, if you got that right, absolutely brilliant. This is the equation that is perpendicular to this equation and passes through those points. All right, if you got halfway, you're doing well. So don't be despondent or anything. Don't think you can't do this. This is a really nice, neat piece of maths, okay? And that becomes very, very easy with practice. So that's all you're going to need. Just practice, practice, practice. Okay, I'm going to do one more question, and then I'm going to leave you to it. So 2y equals 6x minus 1, and I've got minus 6, 1. Again, like with the last one, because this one feels a little different. The last one had a decimal in, could have put you off. This one might put you off. If it does, just have a go first. And if it does, if it really throws you, hit play to the point where you needed to understand something, and then hit pause to try and finish it off from there. Okay, but pause now and hit play when you're ready. Okay, so I'm thinking that this might be upsetting some of you. It doesn't fit the formula to have a 2 in front of the y. Yeah, if we look at our formula, we've got y minus y1 equals mx minus x1. There's nothing in front of that y, so I don't want anything in front of that y. If I do, I've got to deal with it. So what I'm going to do is I'm going to pick up this 2, and it's going to land on the other side as a divide by 2. That's going to rewrite my equation. I'm going to pop that out of the way. To y equals 6x divided by 2 is 3x, and negative 1 divided by 2 is minus 1/2. So that's going to rewrite this. I've got my x1, my y1. I have a gradient of 3 in the question. So my perpendicular gradient is going to equal minus 1/3. I really like writing it like that. That's going to equal 1/3. And now I can put all my information in. Okay, so let's move this up a little bit. I've got y minus 1 equaling minus a third x minus 6. So easy to go wrong there with those negatives because it's already there. You don't want to write it a second time. Really important that you do. Loads of negatives, so we've got to be very, very careful. Even if you're using the calculator, you've got to be making sure that you're careful as you're entering it in. So I've got y minus 1 equals minus a third x. This is obviously going to become plus 6. But then what I've got, I'm going to write it over here, is I've got minus a third times by positive 6. Okay, so I just got to be, like I say, really, really careful of that. That's going to give me negative 2. And then this minus 1 is going to come across and land as plus 1. So I've got y equals minus a third x minus 2 plus 1 is minus 1. And then that is my final answer. That is the equation perpendicular to this original equation, which we had to manipulate, passing through these points. All right, so they can do some little nasty things to you. There's no point in us not being familiar with it right from the off, okay? So I've done you a set of parallel styled questions, a set of perpendicular style questions, and all the answers are here. Okay, so just think about taking a break. This has been a massively long session. And then, yeah, just sort of scroll through, pause the screen at the right place for you for each section. And hopefully it will go brilliantly. And I will see you in the next session.